Okay, so today we're going to talk about power. Now, we talked about power before, and we said it was how fast work gets done, or how fast energy is used, okay? And it still is that, all right? The symbol for power is still P, and the units are still watts, okay? However, we're going to take what we knew before and kind of apply it now to electricity. So previously, we said that power is how fast work, when work is a type of energy, so in this case we're going to say it's the change in the electrical potential energy over time. So it's how fast work or energy is used. Okay? And then we're going to substitute in an equation for our electrical potential energy. We're going to substitute in negative Q times the electrical field times the displacement over the change in time. Then we're going to break this equation up. So we're going to stay with negative Q over the change in time times the electric field times the change in displacement. This is current. Okay? But the negative, we're going to move over here. Okay? So just move the -1. It's all multiplication, but move it over. So multiply this by -1. So now I've got current, and then negative the electric field times the displacement is our potential difference or voltage. Now, once we start talking about circuits, we kind of drop the delta when we're talking about potential difference, and we just use the letter V. Okay? So if you look, now we've got an equation, power is equal to current times voltage. And that is what we have written down in the slide back here. Power is equal to current times voltage. Now, we can derive these other equations as well. Okay, we've got Ohm's law. Voltage is equal to current times resistance. Well, let's go ahead and substitute this in for the voltage. Well, if we do that, we get power is equal to current times resistance. So power is equal to the current squared times resistance. Equation number 2. If we want to get this equation, first we have to solve Ohm's law for current. So current is equal to voltage divided by resistance. Just divide both sides by resistance. Okay, and we get this. Substitute this into our equation, and we get power is equal to voltage divided by resistance times voltage. So power is equal to voltage squared over resistance. And that is our third equation. Now, another thing we need to review here is just our energy. Energy is going to be equal to power times the change in time. So if you have a powerful light bulb, like a 100-watt light bulb, and you leave it on for 24 hours, it's going to use a lot more energy than a 60-watt light bulb on for 24 hours. Okay? Now, that 100-watt light bulb definitely burns brighter, but it's going to also cost you more because you'll be using more energy.